Sir, good evening, sir.
Sir, very good evening.
Sir, very good evening, sir. Very good evening, sir. Sir, we'll start within another 2 or 3 minutes, sir. Shall we wait for
Sure,
2
sir.
minutes? Okay, sir. Okay, sir. Thank you, sir.
Arun Prakash, sir. Good evening.
Sir, very good evening, sir.
Yeah, how are you, sir?
Good, sir.
Yeah, fine. In another 2 to 3 minutes, we will start the session, sir, please. Huh?
Sure, sir. Sure.
Okay,
Looking
okay.
forward.
Thank you.
Sir, shall we start, sir? Sir, shall we start, sir? Am I audible, sir?
Yes, Professor. I think we will start.
Okay, sir.
Arun, sir?
Sir,
Yes,
am I
sir.
audible, Arun, sir?
Yes, sir. Loud and clear.
Okay, sir. Thank you, sir. Thank you, sir. Good evening to one and all present here. On behalf of Sri Krishna College of Technology, Coimbatore, we take immense pleasure in welcoming our today's resource person, Mr. Arun Jayaprakash, Director and CEO of Aviation Technologies Private Limited, New Delhi. Along with Dr. P. Pradap sir, Professor and Head, Department of Mechanical Engineering, and Dr. I. Batmanaban, Professor and Head, Department of Civil Engineering, my fellow colleagues and all my participants, I welcome our resource person to today's FDP. We are very much happy to have you, sir, as a resource person for 1 week faculty development program on innovative and emerging thrust areas on civil and mechanical engineering, which is scheduled from 11th of February to 17th of February. In spite of your busy schedule, you have accepted our invitation and agreed to act as a resource person, sir. So once again, I welcome you, sir.
Thank you, sir.
Thank you, sir. Over to you, sir. Over to you, sir.
Okay. Is my screen visible and I am audible?
Yes, sir. Yes, sir.
Okay, great. First of all, I would like to thank Dr. Pratap sir, head of the Department Mechanical, and Sri Krishna Institute, Coimbatore, along with Institution Innovation Council for providing an opportunity for me to interact with all the faculties from various institutions. It's always privileged to interact with the faculty team. Okay. So without further delay, let me go for today's presentation on the emerging thrust area, which is drones. So the topic today we're going to discuss is the application of drones for mechanical and civil engineers. And myself, Arun J. Prakash, I'm the Director and CEO of Aviation Technologies Private Limited, New Delhi. Okay, so this will be the today's agenda, where like we're going to talk about some drones, UAVs, and unmanned aerial vehicles. Then the different type of drones that is normally used for commercial application, and then we will focus on the role of mechanical engineers in terms of this drone technology, and then the application to civil engineers, how this drone is playing a huge role. Then we will look into few more interesting applications that is pertaining towards the commercial sector, and what are the challenges that this sector is facing, the growth and market scenario, the job opportunities available for the students, and then we'll introduce about our company, and then we'll wind up with the Q&A. So to talk about this drones or unmanned aerial vehicle, by definition, an unmanned aerial vehicle means there is no pilot, no co-pilot or navigator. They are all removed by a flight control computer and replaced by a flight control computer and a radio communication link. The user will be standing in the ground like this with a remote control, and they will be able to give some input signal so that the drone can fly wirelessly and can be controlled in air. So this is the basic definition for unmanned aerial vehicle. So whenever we talk about this unmanned aerial vehicle, another term that comes into picture is the drones. So what is the basic difference between a drone and unmanned aerial vehicle? Drone itself is an unmanned aerial vehicle, but it has little bit of level of automation that makes it to be little different from UAV. That is like automatic takeoff, automatic go around and gather some intelligence and come back and land itself. So these kind of intelligent pre-programmed behavior is what makes a drone more intelligent. So this is the basic difference basically between a drone and an unmanned aerial vehicle. So whenever we talk unmanned aerial vehicle, the first thing that comes is the military application, because drones are not something very new. It's been with us more than a century, where Austria attacked one of the country using balloons carrying weapons. So that is how, the application of drones started in protecting the country and its borders. So over a period of time, there are many wars, and many countries have fought to protect their borders and protect their people. So during this war scenario is where the government invest a lot in terms of technology, R&D, to develop products and solutions to protect the country. So in that note, like all these drones were developed over the period of time. And you can see here, like some of these drones weigh from just 18 grams to several tons of kg, carrying from a small payload, camera as a payload, to even a weapon, and drop on enemy target. That much capability is there. So gone are those days where these unmanned aerial vehicle or drones used primarily only in military applications. Now we have a number of commercial application where it makes our life very easy. So in the commercial market, if we look into it, these are the different type of drones that are used in commercial market, where multi-rotor drones, fixed wing drones, and single rotor and fixed wing hybrid VTOL. Uh, so every drone has its own pros and cons. So depending upon the application, one has to select the right choice of drone. Say for example, if I want to compare with multi-rotors with the fixed wing drones, multi-rotors has the advantage that it has a VTOL. VTOL means vertical takeoff and landing. It can take off in a very small space, and it can fly around and come back and land in that small space. Whereas fixed wing, it requires a large open area to fly and to come back and land. That's a drawback of fixed wing, which we cannot use it for places where some infrastructure or some trees or power lines are there. Another advantage of multi-rotor is it can hover at one place. When I say hover, means it can stand in one place so that the camera can be tilted, zoomed for some inspection or surveillance, those applications. Where fixed wings, they cannot hover at one point. It has to move forward. So that's drawback. But with respect to endurance, how long the drone can fly, the fixed wing have an edge over the multi-rotor, because multi-rotor, 4 motors for a quadcopter needs to draw their power from the battery, whereas in fixed wing only one motor is there. So obviously it is going to consume less power, which means it's going to fly for more time. So that's why we use fixed wing kind of drones for larger project area for mapping or applications, and multi-rotor for small area of mapping or surveillance applications. Single rotor drone is also capable of flying for long time. It's similar to the helicopter, but it is very difficult to handle in terms of stability. So that's why mostly people avoid that. And fixed wing hybrid, it has the best of both the worlds, because this hybrid can take off like a multi-rotor and fly like an aircraft. So it has best of both the worlds of endurance, as well as the capability of hovering at one place and vertical takeoff and landing. So this is the introduction about the different drones that's been used in the commercial market for different applications. And all these drones are the one, like more customized, with more power and more payload carrying capability in the commercial markets. So with respect to aeronautical or mechanical engineering, what will be the engineer's role is what I'm going to present in the upcoming slides. So this is the Department of Defense Standard 2167A for any product development for drone, or any product, let it be. Say for example, the entire drone I have to design and develop, or a small portion or payload I want to develop for the drone, it has to go through all these process. The upper one is about the hardware development, and the lower bottom one is for the software development. Say for example, today a customer is coming to me and saying like, Arun, I need a drone for say for some inspection purpose. It has to carry a camera payload of say 2 kg, and it has to fly for more than 30 minutes. So these are something the customer is sharing his requirements, his or her requirements. So based on the requirements, then only the drone will be developed. So that is why the first step of this process is system requirement analysis / design, which means you are hearing the requirements from the customer, and then only you are going to develop it as a product. So once you hear it from the customer, then you will have certain review meeting, and then only it will go for the hardware requirement analysis, where you will try to understand to develop this drone and meet customer requirement, what are the different hardwares we need to use in terms of engines or in terms of motors, in terms of payload, capacity. So we understand what is the hardware, requirement analysis, and then we go for the preliminary design. So preliminary design is where the design will be done based on the selection of hardware components, because the primary requirement is you have to accommodate these components inside the drone for it to carry. So that is how the preliminary design will be done. Then after preliminary design, a review will be done, PDR, that's a preliminary design review. Then after the team agrees to the meeting requirements, then it goes to the detailed design, where the tools like CATIA or SolidWorks or Autodesk Fusion 360, the detailed design will be done in a 3D model scale. And then again a critical design review will happen to understand whether this design is meeting all the requirements, and then it will go for fabrication and testing and final evaluation as a product. So this is how the cycle will go for developing the entire drone, or even a small payload you want to develop also. This is how the cycle goes. And the same goes for the software in terms of coding and testing. It will go instead of fabrication and production. So this is a process that will be standard, that is followed in any industry. And when you talk about the phases of design, so design basically has three phases. So one is the conceptual phase, the second is a preliminary phase, and the third one is detailed phase. In conceptual design, what you have in your mind, you will just express it in a paper pen or paper pencil, just a rough sketch, like rough figure, like you just scribble it around or draw it. This is how I want the drone to be, or this is how I want the payload to be. You do a design, rough design on it, so that becomes the conceptual design. So when you give some values to it, like say the arm length should be this much, or it should have the landing gear of certain height. When you start giving the values, and then it becomes a preliminary design. You are able to make it more meaningful, and it will become detailed design when you understand every inch or parameter of your design. Then you can use software tools to design your own drone, whether it may be a multi-rotor or whether it may be aircraft. You can use the softwares to design it entirely as a 3D model, and you can understand how all those different equipments and things will fit in the drone, including the payload. So that is how the detailed design level the people have to do. So once your detailed design is done, then very important phase that comes into picture is analysis. Because you have developed, designed, it doesn't mean that it's going to fly or it's going to do great, unless and until it does certain simulations successfully. Simulations like aerodynamics, structure, and vibration. I believe all these three can be related to even civil also, because even civil, the tall structures also is developed with respect to do some aerodynamic analysis is done. The wind flow over the structure also is being studied for civil engineers, and structure plays a huge role even for developing a drone. For civil engineers, even for the structure, like they do a lot of BIM and a lot of analysis they do. So and vibration also plays a huge role in both the cases. Like in drone, vibration we cannot allow, because these vibrations can make the drone unstable, and it can crash also. So we need to damp out those vibrations. So all these different type of analysis is supposed to be done by the mechanical engineers. This will be the major role, I believe, like for the mechanical engineers, right from the design concept to the complete analysis, and showing it to the end user, that this design will definitely work, and it can carry the payload, it can meet all your requirements. So this is a major role, like for mechanical engineers. And this is some simulations what they can do in terms of aerodynamic analysis. This is a simulation of static stress analysis, static flow analysis, aerodynamic analysis of multi-rotor. And this is a quadcopter structural analysis to understand how much load it can withstand before it breaks. So that is done, like again using the software tools. So you have different tools in the market to do those kind of simulations, to understand how your design will meet the end requirement or not. So moving to a little bit of electronics also has to be a part of now mechanical, because nowadays the EV vehicle is coming into picture. So all your engine kind of vehicles are now slowly getting replaced by EV electric vehicles. So, and even aircraft industry is also looking, electronics, motor based, aircrafts as a transportation, and even drone taxis are also coming into picture. So we cannot neglect, the use of these electronics in terms of mechanical, engineering. So mechanical engineers should have a clear understanding of these components, different components that's used to build these drones. So these components we call avionics. Avionics stands for aviation electronics. How are we going to integrate all these different systems is also a knowledge that is required for the mechanical engineers. Starting from motor, BLDC motor, it's a brushless DC motor that's used in the industry for drones. And the running of this motor is controlled by a device called the ESC, that is the electronic speed controller. So this is the one which controls the RPM of the motor. So the net torque is controlled, and the drone takes different direction based on the RPM reduction. And flight controller, it's a heart of your entire drone. So this flight controller comprises of different types of sensors into it, right from 3-axis gyros to 3-axis accelerometers. Then you will have a magnetometer for direction, or barometer for altitude, and GPS systems for position holding. So all those different sensors are included, like in the flight controller. Then they should also have the knowledge of different transmitter receivers, wireless transmitter receivers, to communicate with the drone, to and fro. And the power system, like the battery, mostly lithium ion and lithium polymer are the one, like it's been currently used in the industry for the commercial application. So one has to have an understanding of what should be the voltage range that's required for my payload drone, or what should be the current rating of that's required, that will meet my endurance need of my drone. So all these understanding is very important for the for the mechanical engineers. So the when we talk about the flight controller, there is n number of flight controllers available in the market. So one has to have a proper understanding of what type of flight controllers I should select for my own drone for certain applications. So the choice of this controller depends upon various parameters. Whether you want to develop the drone as a proof of concept, then you can go for a manual drone and just manually fly it, and you can show them the proof of concept of whatever the project you are trying to do. Or if the project intention is to show it as autonomous capability, then you need to select a flight controller that will allow to integrate GPS kind of system, where autonomous navigation is possible. So that kind of flight controller you have to choose. And again, the controllers will be also divided based upon whether you're going to use it for a fixed wing, or whether you're going to use it for a multi-rotor type of drones. And the classification also you can do, whether it's a open source programmable, so that like you can do some Python coding or something and tweak it little bit as per your requirements, or it's a closed one, like where it's not allowing you to do any changes. And the user friendly interface, whether you are able to do all the interface properly, it's friendly. And finally, the budget, that's also major concern, like when you develop a drone for a particular application or project, whether these type of controllers fit into budget. Because as the number of features, it goes higher and higher, the budget also climbs up accordingly. So one has to decide based on the application and the need, what type of flight controller one has to choose. So this knowledge is also very important. And different sensors, you have n number of sensors, like temperature, pressure, humidity, UV, gas sensor. So one has to also have the knowledge of different sensors that can be integrated with the drone, so that can do a particular application. Say for example, in a power plant, or like some chemical plant where some gas leakage is happening, where a human cannot go there and check what is the intensity of the gas. So here, like drone can come into picture, where you put the sensor onto it, fly it, so it will fly into that atmosphere, and gather the information. And once it is back, like you can get maybe wireless data, or you can get all the data through the sensors. So in that way, whatever the sensor you put into the drone becomes that application. You put like a spraying tank into it, like then it becomes a spraying drone. You put a RGB camera, you can use it for mapping. You put a zoom camera, you can use it for surveillance and inspection. Thermal camera, then for solar panel inspections, night surveillance. It all purely depends upon what type of different sensors you're gonna put into it and accordingly use it. Accordingly, it's going to collect all the data and give it to you. So one also have to have a clear understanding of different sensors that can be integrated to your drone, for a particular application. So that knowledge also, I believe, like should be important for mechanical engineers. Then high frequency structure simulation. This is, again, the frequency simulations like that normally electronics people use. So that this also some, one can prefer, like, if they want to do some frequency analysis also is possible. So in case of application wise, if you look into it, like last mile delivery is one of the important application, where the item, whatever the person is ordering on a e-commerce platform or like booking things, it has to come from a warehouse to the person's house, like where is he or she is ordering. So this is a major problem where the vehicle get into traffic, or like you won't be getting the things in time. So this is where like drone comes into picture, where you order the things, where like the drone can bring whatever the things you have ordered in say half an hour time or 1 hour time, and it can drop it to your in front of your house or top of the roof or like somewhere. So this makes the last mile delivery problem very easy in reaching the customer in a faster rate. Many companies are working towards the delivery application, and even many states they are working on already testing is happening in terms of taking blood samples or urine samples from one location to remote location. Even postal department has recently tested the drone for postal delivery from one place to another place. So in that, and Zomato and Swiggy is trying to experiment with sending groceries faster to the end user through drones. So already a lot of testings are happening in Bangalore and in Noida here in Delhi NCR region. So a lot of things are already happening. So Amazon here, like uses the mothership kind of concept, where the main ship will carry multiple drones with payload delivery, and it will fly to a particular region, where again inside that hundreds of drones will come out and deliver all the delivery items to the customer, and it will go back into the ship again. So the concept something like this, they've been testing it around. And food delivery, as I said before, like Zomato is also working, Uber is also working, such kind of application. Medical supply, already many companies are working on it nationally and internationally also. Zipline is internationally a well-renowned company which is working on African base as a base, Africa as a base, where they supply these blood samples to hospitals, or delivery, all those things they've been doing that. And drone ambulance is also another application, considering the traffic situation that is in the metropolitan cities like Delhi, Mumbai, Bangalore, and Chennai. Any ambulance that has to travel in a peak hour from point A to point B, it's very difficult to reach the person who is in need. Where drone ambulance can at least provide some first aid, like it can reach in a shorter distance, because it has to just take off and go in a straight path and reach the destination. So it can become a lifesaver application also. That is also some application area where people are working onto it. Future is like, yeah, this Prime Air, like Amazon is already working on delivery. This is there. This is another very futuristic development in the drone side, is the drone taxi. So it's unmanned aerial vehicle capable of transporting people, or like even people are using it as a cargo to ship a huge containment from point A to point B, whether from sea to land area, or from city to village or remote places. So this has been very useful. And in all over internationally, like around 70 plus companies are working on this drone taxi concept, and many companies have already tested their drone taxis. You can see already here, like these taxis are flying around. This is also like some place where the future of transportation is going to be. So mechanical engineers can focus in these areas also. So the benefits of this, using this technology, this having this drone taxi, is obviously it's going to beat the traffic. It's going to fly in the air at fixed altitude, ease of travel, and quick to reach, obviously. But some of these are going to be pilotless. Some of these require maybe pilot, like a normal taxi kind of thing. The pilotless like will become like a Ola or Uber kind of app, where you can book it through the app, and the taxi will come, and you can get into it, and it will take off to a predetermined altitude, and it will drop you to the destination through the app, which is you have put your destination. So the same way how your normal Ola Uber works, the same way only it's going to work. And even Uber has invested in 5 companies and for the drone taxi, and they strongly believe that India is a very good market for drone taxi, considering the all the traffic situations in these metropolitan cities. And even the last figure of drone taxi, it is one of the from the Uber only, investment with respect to Bell company internationally. So they, during a conference, they have launched this drone taxi for public view. And of course, like it's going to be cheaper when compared to helicopter or any other type of transportation. It's going to be, so once the frequency is going to be increased. So these are some of the 18 leading, world's leading eVTOL or like flying car or flying taxi manufacturers. So you can see the big, company names here, right from Airbus, Boeing. The Bell is the one I was talking, like Uber, collaborated and they launched. Volocopter already, they tested their drone taxis in Singapore and Dubai, I think. And Dubai, I believe, like will be the first country, like maybe like they'll launch these kind of taxis very soon, maybe by next year or 2024 or maybe 25. Before that, I strongly believe like these taxis are going to come into picture for transportation. So these are some of the other companies where these drone taxis are there. This is Lilium Jet company. This is EHang 184 drone taxi. Again, it's a small single seater, 2-seater concept, like taxi. Yeah. So you can see that it's a touch display. You just enter, put your destination. So all predetermined, altitude, it will fly, and it will, take off and drop you in the respective destination wherever, you want to get down. So this is, till this, it's with respect to mechanical engineers, like, in terms of starting from the product development or as a whole of drone, or a component or subsystem of a drone. Like if they want to develop, what is the procedure they have to follow, and the design phases, plays a huge role, and the analysis and the simulations that they have to do, and even the later part of integration of various components into the structure and testing. So they play a huge role in terms of like the developing the entire ecosystem. I believe, like more or less, like lies or depends on mechanical engineers or aeronautical engineers, where mechanical is the core one. So for even for aeronautical, so it plays a huge role. They play a huge role, I strongly believe. So moving to the second part, like where with respect to civil applications, I'm going to talk the role of drones here. So remote sensing application is one of the major application, where it is done technically by gathering information about an object without making any physical contact, which means remotely you are gathering the data. So how it is traditionally done is through satellites, because sun emits the heat source, and every object in the earth has a tendency to observe this heat radiation and emit the heat radiation. That emitted heat radiation is reflected or observed by the satellite based sensors, and through that, like we gather the intel about the ground data. So it is done through satellites, it's done through even aircraft. sometime carrying bigger sensors and capturing data. And the later stage at the last is what the drone technology, where we fly the drones around say 200 feet or 400 feet maximum, where we get crystal clear accurate data when compared to any other form of gathering the data for remote sensing applications. So this is how the traditional process of remote sensing happens, like where sun is the energy source which emits heat energy. The target, every body, like every object on earth, observes this heat radiations and emit heat, which will be observed by the sensors over there in the satellite, which may be a hyperspectral or synthetic aperture radar, or different sensors are there. So these sensors will capture all those information and give it to the processing station. The processing station, for example, IARS, Indian Institute of Remote Sensing in Dehradun, like we have a processing station of ISRO where they have the access to satellite image gathering, and there they have the team for different type of analysis, whatever the analysis they want to do with respect to say the land use, land cover, or like the agricultural growth in a particular region, or the flood analysis or flood prediction in states like Uttarakhand or somewhere like hill stations. So all those teams will do all those analysis and give to various other departments for application and implementations. So you can see here, like how a typical satellite image of an agriculture area or an urban area looks like. So the left side is agricultural area and the right side shows the satellite image of an urban area. So here I would like to compare, satellite data is the one, like, we were mostly relying on early. So now is what the technology, drone technology has come and, trying to overtake. So what is the pros and cons, like, is what I have put in the upcoming slides, where we will try to understand, the drone technology with respect to the satellite based data gathering. First is real-time availability. So real-time availability, when we talk about it, drone has the more advantage, because today, if I want to do a survey in Sri Krishna College of Engineering in Coimbatore, like, then immediately I can take a drone, I can go there, I can fly the drone, I can do the survey or gather the information, and then do the post processing, get the intel, whatever I require. So which means, like, whenever I want to do any survey or anything, immediately I can take the drone, go there and do it as per my wish, which means real-time availability. Drone has a very good advantage. When it compared to satellite, it's not available as per our need, because these satellites are orbiting at a very higher altitude, and it will pass on to a particular region only on a particular day or a week. These satellites pass on. So which means immediately you want to gather data is not at all possible, because these satellites they pass maybe weekly once, or like the time is also a constraint. So if it comes in a cloudy time also, like, it's a issue. So all these constraints make real-time availability of satellite data a little bit disadvantage. Range of drones, if you see, the range of drones are limited to a particular region. Say, for example, a drone flying at 400 feet can gather intel around, say, around 80 or 100 acres of land. It can able to gather data, and after that, the battery drains out. So which means the drone has to come back again for a change in battery to do further survey and things. So that's little drawback, like you need to do again and again this battery change for every 20-30 odd minutes. Whereas in satellite, since this satellite is put into a very, very high altitude, so in one swath it will cover the entire city data. So for large scale, that kind of application and analysis, satellite has the advantage of using the data sets. And when it comes to weather, of course, drone has the advantage, because irrespective of whether it's cloudy, it's going to be sunny, these drones are going to fly at a low altitude of, say, around 200 feet or 400 feet, and gather all the images, data, whatever that's required for the surveying process. Whereas when we compare this with the satellite based data, these satellite sensors, they cannot penetrate this cloud and collect information. So if it is cloudy, even though it passes the region of your interest, still, you won't be able to use the data for your application. So unless and until it's going to be microwave, because microwave can penetrate the cloud, but you will get the data in black and white. You won't get the actual features of the ground data. So in that note, cloud can become a drawback for satellite based data. Cheaper for surveying smaller areas. Of course, drone is very cheaper. So once you invest, in procuring a drone, so you can do survey of say 40 acres or 100 acres, like depending upon whatever the altitude you fly. So small areas you can always you can do the survey. So it is always worth for the money you're gonna spend over there. So it is a really good investment in investing on drone based surveying. So satellite is cheaper for surveying the larger areas, but the difficulty lies here is difficult to get the live satellite data from ISRO or from IIRS, because it's not available for commercially, for anybody. So whatever the data we get is maybe a week old or month old or maybe year old. So those kind of older data is what is provided for common users for academic or research purpose or utilization. So in that way, it's very difficult to get the live data. Whereas in drone, you will get the live data about the field or about the surface immediately. So when it comes to geometrical resolution, it is very important, because that shows how clear the data set is going to be. So as the figure shows, as you go higher and higher, so your images starts pixelating and you won't get the clear data. So the maximum available panchromatic resolution is 25 centimeter, and multispectral resolution will be around 1.2 meter of error. Whereas these drones are flying at a very low altitude, so you can get the geometrical resolution of even some case studies are there where less than 1 centimeter accuracy is also achieved using drone technology. So this is for the audience, name the Indian satellite launched by ISRO for achieving 25 centimeter geometrical resolution. So any idea in the audience is there? They can put it in the chat box. So in the chat box is open. So the question is, anybody aware about the satellite which can give you the 25 centimeter resolution? Yes, we are getting some answers. Cartosat 3, great. So yes, Cartosat 3 is the right answer. So we'll go again. Yes, Dr. Muthukumar, Dr. V. Satish Kumar, Satya Prabhu, Ishwar and Nandiappan. So everybody is right. Cartosat 3 is the one which gives that accuracy. Okay. So this is how the geometrical resolution of satellite versus drone looks like. If I want to give you a clear picture, so here you can see on the left side is a satellite based data, where if you want to closely observe any area, if you keep on zooming, this is how the the data get pixelated. Whereas here, drone based data, you can see here, you keep on zooming, even the clarity is so good, you can do all the physical measurements also. For example, here the solar panel on the rooftop, here you can even do the measurement, how much meter is the width or length, or what is the area that's available on the rooftop for the solar panel installation or something like that. So all the data are like, it's very clear for us to understand. This is what is helping, even in the survey process, to get accurate survey results. Okay, so we talk about satellites. So can you guess what it is? Again, for the audience, can you guess what it is? In the chat box. So can you guess what this is? Okay. Space station, satellite in moon. Space. Okay. So yeah, it is International Space Station, basically ISS. Okay. So it is International Space Station. A lot of research happens here. In zero gravity, they try to understand and do a lot of experiments over here. It is International Space Station. So now the next question comes here is, can you see this International Space Station through naked eye, standing on your house top, terrace, or in the garden, somewhere on the roadside, or in your colony garden or somewhere? Can you see, is it possible to see this ISS through naked eye? Again, put your comments in the chat box. It's not possible. No, sir. There is one yes. No. Okay. Okay. There are more of no. It's not possible. Yes. No. Okay. Only 5 people have replied. Okay. It is possible technically. Yes. Dr. V. Satish Kumar is right on this note. It is possible to ISS. You can see it in naked eye. So how you can see is, it's possible only during night time. Even there is apps are there to track it. There is even in Android Play Store, you can search ISS tracker. That is International Space Station tracker. So what it will do is, it will, once you install and put your location, it will take your current location wherever you are staying. Say for example, you are in Coimbatore, in some particular location. That particular location, with respect to latitude, longitude, and altitude from sea level, it is taken as an input, as a reference. With reference to this, when is the next time the International Space Station pass through India and it passes above Coimbatore, the app will tell you, and the time also it will tell you, and the direction also it will tell you, whether it will come in, you can see in the north direction or some 30-degree or south. So like that, like you can easily see. But how it will be visible, how I should say, like it is ISS, it will appear as a brightest star in the sky, but it will travel in a very high speed in a straight line. So that is nothing but your ISS. Okay. So of course it sounds crazy, like whenever you say somebody like it's possible to see ISS, like when it is in so much high altitude, how it's possible to see. But yes, you will be able to see. Even I have seen 4-5 satellites at a time. Other satellites are also visible, but it will be like a normal star, but it will be constantly moving around in an orbit, straight line. So with reference to some point, if you keep on staring at some location, you will be able to see these satellites, which is moving at higher speed, because these satellites move in the low earth orbit, like in 1 second it will travel 11 kilometers. Okay, in 1 second of this much, 1 second 11 kilometers is what it can travel. So that is the speed it will go. So in space, so from ground, like we can see that at a very good speed, it's moving in a straight line. Dark bright star, that's how ISS you can track. So next time you guys can install the app and try to track it and see it for yourself to believe it. Okay, so let's move further. Okay. With respect to civil, these are the traditional surveying instruments that's used for the surveying process. That is theodolite or chain surveying, tape surveying, level stuff or total station, where people focus to understand what is the distance and the elevation. So this is how the traditional work is done. So now all this traditional work is replaced by drone-based surveying, where drone is taken care of all these process, and it makes life very very easy for civil engineers. So this is Avio M1, our professional drone. Internally we have designed and manufactured for mapping application basically. So this drone has a flight range of 5 km and 20 megapixel camera it has. So one click automation is there. So the entire area, whatever you want to map your campus or anywhere, so it can be done. It has a flight time of around 30 to 40 minutes. It can fly. It has a collision avoidance sensor at the front. It has a PPK. Sorry, there is a mistake. It's not PPL. It is a PPK enabled for high accuracy. PPK is precise positioning kinematics. To get that precision of 1 centimeter or 2-3 centimeter accuracy level, to get that high accuracy, PPK sensors are enabled into it. Multiple fail-safe features are there, so that in empty battery it comes back and lands. Even if it goes out of signal, it comes back and land. Battery drain, it comes back and lands. So all these multiple fail-safe features are there, and it comes with an integrated remote and wireless live video also it transmits. So this kind of professional mapping drone, once you use it for surveying, all you have to do is, like in an app, like you have to set a plan. Which is the area I want to cover? What is the altitude I need to cover? Immediately it will tell you how much acres, how much images it's going to capture, or what is the battery level that is required. Sorry, what is the battery level that's required to cover this entire area. So you can see here some 93 acres are covered in 2 batteries and 30 minutes. Just imagine, in 30 minutes of time you are covering 93 acres of area for mapping application. So that's the beauty of it. So this is a sample, like one of the customer location during our workshop training program for the civil engineering students. So we have captured their campus, and we have created a 3D model of a small portion of their campus. So here you can see, once the 3D model is created, the civil engineer need not to go to the field for measuring all the data. So here you can do all the 2D, 3D measurements. Say, for example, I want to do a 2D measurement, click around the 2 points, select the distance. It will tell the distance in terms of meters. So in terms of surface area calculation, click in 4 places, like it will tell you what is the area in meter square. You can understand what is the empty land area or build area already. So you can measure very easily. Even you can do volumetric estimation. That's where mining industry is using this thing. Say, for example, some construction material is dumped over here in the campus site. I want to understand how much material is dumped. So you just select the points around the material. So it will tell you the cut volume and fill volume in meter cube. So this is how the drone technology is making life easy, which means you need not to spend hours and hours and days, like on field for gathering all the elevation points and datas. All you have to do is, like do a flight plan, fly the drone, and collect the images and use the software for post processing. So this is done using Bentley, and we are the technical training partner for Bentley all over India. So using that, like we've been sharing this knowledge to all over India to civil engineers in academic institutions. So in this way, like you can save a lot of time. So apart from this 3D model, what are the other outputs you can generate? Less, you can generate orthomosaic, you can generate contours, you can generate DEM, whether it can be a DSM, digital surface model, or terrain model, or the 3D map. You have already seen, like the output, how it is. So when I talk about orthomosaic, ortho photo is nothing but a 2D view of your customer location. So this is a customer location, assume. So what is the top view, and the 2D view is what it gives. It is basically an image which is rectified for all the corrections, geometrical corrections, the earth rotation and all the distortions is removed, and it gives a scaled version of your actual customer location. Here you can do all the 2D measurements, like what is the length of the road, or width of the road, or the area of the build area or empty area. So all those measurements can be done. This is how smart city plans are done, like using drone. So you do the survey, you plan where you want to build a school or colony or like medical facility or dumping area. So like that, like every plan is done like through this drone based data. Contours are the map that joins the same height. So which means like these lines are going to tell what is the elevation that's present in the surface. Because before start any project, one has to understand the elevation that's there in the site, and they have to level it. So they need an understanding of these elevations in the surface. So to measure all the contours also, your drone data helps out. Digital surface model. So digital surface model means like whatever the object that is there on the earth, whether it can be a tree, building, man-made objects, everything, car, whatever you park, or stone or plant, or everything is there, will come into picture here. So everything, trees, buildings, everything is included into it. So all those data you will get as a elevation data. You can have the measurement of elevation of buildings and everything that's present on the surface. So that is nothing but digital surface model. Digital terrain model is bare ground surface, which means your trees and buildings are completely removed in this. So without that, like whatever the model you get is what's digital terrain model, because at times sometimes we need to understand the terrain. So this kind of model helps for that. And digital this is a comparison of terrain and the surface model. Then the next one is digital elevation model. So DEM actually represents the bare earth. Here even the natural features like mountains or riverbeds is also removed, apart from removing the trees and buildings. So this is what digital elevation model is all about. So this also you can generate using the software. So what is the major advantage of using this drone technology for surveying is it drastically reduce the time you're going to spend it on the field for collecting data. Say for example, you want to collect data for 1,000 acres of land survey. Even you have a very good team, like it might take a week or more than that to gather the data. That also depends upon how hostile that environment is going to be. Based on that, you will be able to collect the data maybe a week or two. But here, like sorry, not a week or two, it will take a month or more than that. I'm really sorry. A week or two is only a week or less than that is only for drone, because normally 1,000 acres can be done it in maybe say around 2 to 3 days of data gathering and another 2 days of post processing. So maybe in 5 days to 7 days you can generate the entire report and deliver it to the customer. So that is how it makes life easy, right? This 1,000 acres of information in 5 to 7 days, it's a huge thing for infrastructure projects. That is why even governments are using drones for infrastructure project to make sure that in a short timeline they will be able to execute the project, saving a lot of days here. Second is the georeference aerial data. Every image the drone clicks, every pixel of the image has the latitude, longitude, and altitude information from sea level. That is what we called as georeferenced data, and they are of very high resolution, and you can get very sharp as 1.5 centimeter per pixel also, like you can get it. And the difficult terrains, like say for example steep mountains, where there is no road connectivity. We done like some 100 acres of coffee estate project in Chitmangalore. So it's completely hostile environment. It's mountain, it's a jungle forest area, no internet, nothing is there. Hardly you can walk over there, like that much steep. So that kind of terrain, like you just imagine, like in 2 days, like we completed 100 acres of survey we have done. So that is where like this technology can be appreciated, like where these such kind of difficult terrains you can use this to cover the data. Even some dangerous sites or water body sites can be mapped easily using this drone technology. So this is where the major application goes for civil. And more applications are used even in the construction and the mining industry also, where they've been using this technology for understanding the cut and the fill volumes, asset managements, safety managements. They are using stockpile volumes, logistics when they want to refill the inventory. Remotely the owner might be of the site, might be in some other country, but you can generate all this data and lively present it, like he or she can understand what's going on, what is the progress that's going on the site. very easily. Dam inspection, canal dam inspection through drone, it's very, very important, because in our country we have 1,000+ dams, and most of these dams are built a century before, during some king's time. And since it's that much old, it needs very frequent monitoring for any crack or any leakage has to be detected. And since these dam structures are very tall, so you can use drone to fly around, map it, and you can see whether any crack is developed or what's the width of the crack, depth of the crack. So all those things you can measure, so that this kind of inspection data will help them to do the rectification action easily, and so that like it won't lead it to any breakage of dam, and any disaster can be avoided. So in that way also it's been used. Even the PM has launched, a project called Swamvikta Yojana. So even nowadays, we have some disputes, in land records, mostly in villages. This land is mine and not yours. Like a lot of disputes are there. So, and even the revenue department, the papers are decade old and degraded. So they want to convert all these, land data into digitally. And now they are doing it with respect to drones with this project Swamvikta Yojana. Already several lakhs and square kilometers of areas been digitally mapped, and primarily along with the industry, drone industry has helped to achieve that. And the PM has also issued a card, property card, just like Aadhaar card. They have issued property card for your property. So that's how the scheme is using the drone technology. So infrastructure projects, as I said before, like already PM insisted to use this, and people been using, every department is using this drone technology. Survey department, Survey of India is collaborating with many of the private drone companies. They are deploying the drones for digitally mapping the entire country to generate the high resolution maps. NHAI recently also made made sure that like monthly drone survey is made compulsory for all the highway and national projects, to understand what is the progress in terms of construction, or how the roads are maintained in the highway, whether any potholes or like crack or anything developed over the roads over a period of time. So all those data, they've been also using the technology to monitor and understand the highways. uh, Drones, these are some research areas where this is a research area where people are using drone for building some temporary rope bridge. Okay, so here you can see that all these drones are coordinating like a swarms. They are coordinating with each other, trying to build a rope based bridge. So I'll just move a little forward to show you. So it's been programs, and it's been doing, and finally it's been also tested by people walking over this structure to see like how good it is. So you can see here people were able to walk it that much strong, like it's has created. So this is something like in the event of any flood or something where the bridges collapse, so some temporary structure has to be created in that short time. So this is where these kind of technology can come into picture really. This is again construction of using drones. This is again future technology where drone is can be used for constructing your buildings in the near future, where you have to share the design to the engineer, and it will be programmed to do all the construction by itself. So here you can see many drones are coordinating itself to create the such a tall structure, beautiful structure. So this is also under research, and this can be the future, like where these machines can do all those construction of structures in a faster rate, in a more safer way also. Now and then, like a lot of tenders that happens with respect to drone technology in terms of drone requirements for a certain application, where they need to customize and build drones. Even now defense is releasing a lot of tenders for immediate procurement of heavy payload drones and things, where engineers are required to design and develop a heavy payload like 50 kg or 100 kg cargo kind of payload like to carry. So a lot of things are happening. A lot of survey related, projects are happening in several lakhs and crores, like, every now and then. These are some old, tender data. But having said that, very recent tender data also you can find using some tender sites. There are more applications are there. I'll just go little faster because of the time constraints or something. So precision agriculture is another area where the drones are widely used. Here, two types of drones are used. One is the drone with multispectral camera, where the drone can capture the images in the visible as well as the invisible spectrum, and it can help to post process and identify in the entire field where the crops are exactly healthy or unhealthy, using generating the map called the NDVI, normalized difference vegetation index. And another drone type of drone that everybody must be knowing is the spraying drone, where it sprays pesticides or fertilizers into the agricultural crop area, where it not only makes the work very efficient, covering 1 acre in 5 minutes to 10 minutes, where traditionally it takes 1.5 to 2 hours, traditional way of manually spraying. But it also helps the farmers to be healthy, because these toxic pesticides are toxic in nature, and when they walk and do the spraying manually, they tend to inhale those pesticides, and it becomes toxic and become very much hazardous for their health. And there are a lot of cases where people lost their lives because of those incidents. So here it not only makes work efficiency, it also saves the farmer health. So that is one good way to look into this technology. This is a small glimpse of, like, what it can do in terms of the agriculture field. So this is also something we provided to customer as per the requirement, 10 liters or 15 liters, like, we build it and we provide it to them. During COVID, we have seen a lot of application in terms of making sure people follow the curfew, and people who are misusing those things to identify these kind of crowds. We are not following the laws and things. They've been tracked by the police, and they've been chased out. So these kind of some applications, and whether social distance been followed and some spraying is being done. So all those things being done through speakers. They've been police department involved in terms of enriching people about this COVID protocols. And locust control is another application, again, where locust is a group of insects which spreads around say kilometers. It will attack the field, and in 1 hour the entire field will be gone. So that kind of locust is also destroyed using this drone spraying. Other departments, like forest department, can use this technology to identify poachers who kill the animals for the skin and tusk. So there also you can use this technology to identify and catch them. In wind turbine inspection is another major application, because these turbine blades are like normally 100 to 200 feet blade size, and it is difficult for a human standing down to inspect, or climbing high is also a risk to their life. So here a drone can fly and understand exactly which turbine, what is the crack or corrosion is there, you can understand. So solar panel inspection is also another application, where you can use thermal camera to identify whether which solar panel or solar cell is not working, because nowadays every state is moving towards alternate source of energy, and they have now solar farms in megawatts every state, right? Which means these solar panels are spread to several acres of area, where you need to do frequently maintenance to understand whether the efficiency is maintained in terms of some certain megawatts. So to do those inspections, this becomes very helpful to identify exactly the spot faulty cells or panels, so that the engineer can go there instead of wasting time in checking each and every panels. Power line inspection also, to carry the cable from one tower to another tower, also it's helping people. Power line inspection also to check whether conductivity is there or not, any cables are broken, any corrosion is taking place, all those things, like again, using thermal camera you can monitor. These are some of the other interesting applications where drone is used to fly over surface and underwater, and some of were using to capture different views of video. This is gesture drone, so using hand gestures, the drone is controlled, so which means using hand signals and computer vision and machine learning, people were able to program it to understand and give commands. And even people were using to gather intel about a live volcano also, you can see using drone technology. This is the application I've been telling, like drone ambulance. Here the story is portrayed in such a way that the girl is walking with her father in a mall, and the father had a cardiac arrest, and she's calling for emergency. So before the ambulance arrives, the drone arrives there first, and through the camera, the doctors are advising her to put the defibrillators. Normally, defibrillator is the one which gives the shock to recover from the cardiac arrest. So she's been advised to place the chest, leads in the chest, and try to give him the shock. And she's able to do that and able to save his life. So that's how the story is portrayed over here. And this can be a real scenario, like considering the traffic situations in metropolitan cities like Mumbai, Bangalore, Delhi, and Chennai, where it's difficult for the ambulance to travel in the peak hours. Coming to the challenges, there are a lot of challenges also is there in this sector. The one is the battery technology. A lot of things has to happen because the endurance are limited to say roughly 30 minutes or 1 hour. So something like that. So we need to have some technology to have longer endurance so that it can cover a wide range that is there. And another thing, safety is also something has to be taken into consideration because since this is going to fly in a commercial space, you need to make sure that it's not going to fall in somebody's head or some vehicle, or not causing any damage to public or property. So drone ports, like airport, you also need a drone ports that has to be established. And also you need unmanned traffic management system that has to be in picture, because once you give license for all these people to fly in the air, it's going to be crowded like commercial aircrafts, like, and you need a traffic management system to control those traffic, so that safety is brought into picture. So all these challenges many companies are already addressing. So in the coming days, I believe like all these things will be addressed. And market scenario, if you see globally also, this is a very good sector, drone sector. It's growing year by year. And even here, like, as per the FICCI report, the market is expected to go 85 billion. But I believe like it would have dropped a little bit because of the COVID in between. But I strongly believe the cumulative annual growth rate will reach 18 and more than that by 23. And this is how the technology is being adapted by different sectors in real estate, for creating some 3D models and videos. Surveying, already we have seen like how it is used, and agriculture also widely been using for crop health monitoring and spraying. Mining, again they also have some regulation to do drone based boundary mapping and estimation of the mining materials using drone technology. And construction industry is also widely using this technology. And jobs, there are a number of jobs for students in this sector, as an engineer, or as a GIS engineer, or drone engineer, or a pilot. Like a lot of opportunities are there in the private sector, as well as even in the government sector. Also, they also have NAL, National Aerospace Laboratory in DRDO one in Bangalore. They also have a UAV lab. Like they work on different applications in developing drones. So there also one can get into a job. Yeah, so that's it about today's presentation regarding the drone application with respect to mechanical and civil engineers. And I would just like to take few slides to introduce about our company. So our company is established in New Delhi and in the 2018, and we primarily focus on drone manufacturing. We in-house design and manufacture. We provide services such as drone surveying. We also provide imparting skill development training in terms of workshops or STTPs, in academic institution. And we also help the academic institution in establishing drone labs or advanced surveying labs, in the institution. And also we are into services. So in a nutshell, what we do, we are into drone manufacturing. We create our own drones called drone skill development. We do the training, drone lab setup. We've been already doing it to academic institutions. Drone services, we've been doing it for surveying. We have done some infrastructure projects, coffee estate, water management through drone technology. Drone piloting also, we provide training and R&D also for many DST funded projects also. With respect to some faculties, we are together collaborating and we are submitting proposals to DST or CSIR funding agencies. Skill development workshops, these are the workshops which we do in education institutions for drone design and development, or CubeSat, drone surveying, mapping, or control system and modeling of drone using MATLAB. So these are the different workshops and trainings we do in academic institution. And these are some of the labs that we have already established, in some of our customer location. one advanced lab which was inaugurated by Honorable Minister Shri Nitin Gadkarji, Minister of Road and Transport Highways. So he has inaugurated in Jawaharlal Nehru Engineering College, Aurangabad. So we have established a lab over there, and this is recently we have established in Banastali Vidyapith, Rajasthan, Center of Excellence for Drone Lab with them. And a lot of new academic institutions in down south also we are interacting, and very soon like we'll be launching few labs in the down south region in academic institutions too, as a center of excellence and a lab for developing skills or providing skills for the young engineers. This is what we do in academic institutions. We go, we teach them design analysis, and we do some practical flying and things. We also do the training on collecting data and post processing using software, how to generate those different outputs like orthomosaic, DSM, contours, or 3D model. So we do it as a workshop in academic institutions for majorly for civil engineering department. We do that. So CubeSat is something recently we launched. So where we create a cube satellite and launch it through a balloon at a fixed altitude. So it gathers information like pressure, temperature, humidity, UV intensity, all those things with respect to time. So that intel is then plotted as a graph. So that's a 2-day workshop we do it. And somewhere like we are there in the media now and then in our drone expos, or the collaboration with academic institution or the workshops and the lab setups what we have done. We've been there in the media sometime. And these are some of our customers in terms of labs, in terms of value added courses, and in terms of trainings, workshops and trainings. And just thank you for your valuable time, and thank again for providing such an opportunity to interact with all the faculty members in various academic institutions. So if you have anything to collaborate or anything interested to do or work with respect to drones, I'll be happy to associate, and we'll be happy to collaborate as an industry partner in establishing or providing training or whatever that's your requirement. So you can always reach me at my mail ID on, this is my office number. So you can reach me here, and also you can follow us on Instagram, Facebook, or LinkedIn, where we post now and then some job opportunities where students can grab even a job or internship opportunity from us. Thank you once again. So I'll be open for Q&A. So if you are interested, so I'll just go for the main screen. Thank you. Useful presentation. Thank you, Satish sir, VP Pradeep sir, Kopi Pillai, Jyoti Palavesam sir. Thank you. Share your contact info. So I'll put it again. I'll put it. Okay, I'll just share it again the screen so that you can. So this is the contact info. So, or maybe I'll put it in the chat box also. So if you have any doubts or anything to ask, I'll be happy to answer. So I put the contact and mail ID in the chat box. So yeah, Sayed sir, yeah, it's done. So it's in the chat box. Thank you, Ishwaran sir, for the feedback. Thank you, Venkateshan sir. Thank you, Dr. Vimal Kannan. Any questions or anything to ask, I'll be glad to answer. Thank you, Ponuswamy. Can you give some tips to design a drone with a specific application? Yeah, we can, but I need to first understand what is the application you intend to do and what is the entire payload is going to be. So accordingly, only we can suggest whether we can go for multi-rotor or fixed wing type of design we have to go. First, we need to understand the application and specific, then definitely we can help and assist. Thank you, Rajeshwaran sir, Dr. Kumar sir, thank you. Feedback link. Okay, I think that will be submitted by Sri Krishna College. So coordinators, faculty coordinators. Before I thought Troy is a drone, but it shows the future is miracle. Definitely, now that is what I intend to tell people while setting up of lab. This is not a drone now. This has a lot of serious applications. So you have to be very careful in handling. It's not a toy to play, because these are now carrying costly sensors, like not only RGB, multispectral and hyperspectral payloads, which are like 40, 60 lakhs payloads also it's carrying. So a lot of interesting applications are going on. Saravanan sir, like, yes, I have shared the contact. Yes, you can contact me for any assistance for seminar and things. Thank you, sir. Okay, the feedback link is there. So I would request all the participants to give your kind feedback over there. Mafaz Anwari sir, like, thank you for your feedback. Kadirvel sir, yeah, definitely. Yes, you can call me. Currently, I'm in some middle of training today. I had day one of drone design and development training here at Karunya, Coimbatore. So tomorrow is the second day. So I'll wind up tomorrow, and I'll catch a flight maybe day after tomorrow back to Delhi. So probably like after that, anytime people can call, because tomorrow I'll be little engaged with some meetings and this workshop that's currently going on. You all have my mail ID and contact number, so you can always WhatsApp or you can mail me. So for whatever the requirements, so I'll be happy to assist. Thank you, Praveen Rajendran sir.
Sir, this is Satyaprabha. Sir, shall I ask one question, sir?
Yeah, ma'am. Please go ahead.
Okay. Sir, does robotic engineering influence on manufacturing of the drones?
I believe drone is like a little advanced of robotics. Robotics has been there, for a long time. Now people even in robotics are realizing looking into the application, depth of application of this drone technology in various sectors. Slowly, the robotics people are also evolving into aerial robotics, because drone is also a kind of robotics only, but you can put that under the classification of, say, aerial robotics. So in that way, I believe they are also upgrading to this technology, looking into the wide range of application. I won't say there is a competition or something, but yeah. Anything else, ma'am?
Nothing, sir. I had a doubt in that, so that only I asked that question.
Sure, ma'am. Sure. Dr. Jean Roberts, sir, like, thank you for your feedback. Thank you, Satyaprabha, ma'am. Thank you, Sheikh Mohammed Anas.
Sir, if there is no further questions, shall we wind up, sir, or we will wait for some time, sir?
Sure, sir. No issues. Even if somebody post a question, you can mail me. So
Yes, sir.
I'll
Yes,
be
sir.
happy
Definitely,
to.
sir. Definitely, sir.
I'll be happy to Somebody has posted. Okay.
What is the scope
For startups in drones? Huge is what I would say, Silvaraju sir, because the government, right from the ministry to PM to everybody is supporting this technology. See, end of the day, they are also encouraging a lot of entrepreneurs to come into this sector. And for all the entrepreneurs, Startup India is also funding a lot. Many people don't know what is the process of funding. Even we as a bootstrapped company, we also lacked, all this process initially. So we missed a lot of opportunities in terms of applying for certain fundings at the early stage, because you have to apply it in the first 2 years, and we are 4 years old. We have grown up also, so we are not eligible for certain fundings. But having said that, like, lot of scope is there. In terms of any innovative solution you can bring, even a lot of investors are ready to invest in a drone startup at this point of time. That is where, like, I feel like the industry is growing a lot, and the PM's vision is to make India as the drone hub by 2030. So to have this kind of vision from the minister, from the honorable PM, and to make it happen, definitely every ministry has to support, whether it's going to be agricultural ministry, or like it's going to be some road and transport, like how they are using now. So every ministry is supporting to use this technology in one or the other way, which means lot of opportunities, job opportunities are there. Startups can come out with a new innovative some solution as a product, or even as a services. Somebody who has couple of drones can start doing service. I heard lot of drone based spraying service are happening down south, where you give some 500-600 rupees, they come to your land area, and they will come and spray all the pesticides and fertilizers as per your requirement. So entrepreneurs are coming into picture, like here lot of opportunities are there for startups, entrepreneurs, and even for people who have good skill sets, have good scope of getting a job. If somebody knows simply how to fly a drone, easily they will get a job, 25 to 30,000 minimum per month. Just how to fly a drone, that alone will grab a job. If somebody is knowing how to integrate and do all those playing thing, then they will become a drone engineer, and they'll be paid even more. So GIS industry, every GIS industry now needs drone pilot and drone GIS processing engineers, which means there is a demand for people who has knowledge to post process this drone data, because people will fly and collect data. Somebody has to use those data for post processing, generating those meaningful outputs and maps, topography maps, or anything like that's required from the customer end. So people need, like, this kind of knowledge. Anybody have that kind of post processing knowledge, easily they'll be observed in the industry. Vaishali ma'am, please, if you want any question, like, please ask. Training centers for drone operating. If you want to become a drone pilot, yes, there is a lot of training centers are there across the country. Based on your location, what is nearby, you can search. There is a website called Digital Sky. You can Google a website called Digital Sky, DIGITALSKY, Digital Sky. Google the first link that comes. It's a .gov. It's a government Director General of Civil Aviation maintained site. In that website, there is an option called training. So you click the training. You will get a list of companies who are approved by DGCA for providing drone pilot training. So anybody you can call nearby and approach them. So they will put you in a batch, and they will get you trained and become a pilot. So I'm also a DGCA certified pilot. I'm also DGCA certified instructor. So DGCA approved training center is available in our college. Okay, I think you must be then from Hindustan, sir. Kadriwal, sir.
Sir, yes, sir. Hindustan College of Engineering and Technology, Coimbatore, sir.
Yeah, I know, sir. I'm in this field, so I know everywhere, like wherever what is happening. In fact, we are also going to start, our own drone piloting school, maybe very soon, in Chennai. In Chennai is
Okay,
where
sir.
we are
That is
thinking to
what I
start.
want to discuss with you, sir. That's why I asked your freed slot, sir.
Okay, sure. Definitely.
Okay, sir. Tomorrow evening I will call you, sir.
Anything maybe like after 7 would be great. 7.
Okay, sir. Okay, sir. No issue, sir. I'll call you, sir.
Okay. Thank you.
Okay, sir. Future, we can plan for one establishment of a center of excellence in our college, sir, with your organization. So we can discuss with that, sir.
Sure, sir. Sure.
Okay, sir. Thank you, sir.
Okay, sir. Thank you. Okay. Still some faculties are asking for feedback link. Arun Kumar, sir, thank you. Thank you for your feedback. Vanishri ma'am, thank you. Thank you for your feedback. Thank you.
Sir, is anybody want to do a training in drone piloting? You can ask, you can come and contact in Hindustan College, sir. So definitely there is an opportunity to get a training regarding that flying of drones and its maintenance, sir. Sir, I can approach Hindustan College, sir. They can get training in regarding drone piloting.
Sure, sir.
Sir, shall we wind up, sir?
Yes, sir.
Yeah.
I think
Thank
like
you,
I
sir.
won't get lunch also like outside, so I also need to wind up a bit.
Okay, sir.
Thank you, sir.
Thank you very much for your
Very
wonderful,
useful
informative
information, sir.
presentation, sir.
Thank you.
So you have started from the scratch and you have explained how to build the drone and the instruments used in the drone, such as flight controller, sensors, etc., and how to integrate it. You have explained it clearly. So those who are not aware of these things, they can easily understand from your presentation, sir. You have clearly explained about the applications of drones in civil and mechanical engineering, such as drone taxi, geometric, a few of them, such drone taxi, geometric resolution, digital surface model, digital terrain model, etc. And you have clearly explained the advantages of drone technologies and what are the challenges that drone technologies is facing in the scenario, and what are all the future applications of drone technologies. And you have also clearly explained the job opportunities of for the in the drone technologies, sir. So it is definitely it is an eye opener for our participants, sir. Definitely. So we will take it to our students also. Definitely, it will be a very useful thing for our students also, sir. And not only for our students, it is also for us also. Those who are doing their research in this area and those who are applying for funding, so they can use these things for further processing, sir. Thank you. Thank you so much for your wonderful presentation, sir.
Thank you, Srinivasan sir, for that feedback. And I'll also request, please share me also the feedback, whatever the audience are sharing, so that I can also look into it and, somewhere like that can also sometime help us to improve the presentation, or somewhere, something can be positively done. Right?
Yes, sir. Yes, sir. Definitely, sir. Definitely, I will consolidate and I will send it to you, sir.
Sure, sir. Sure. Thank you. Thank you so much.
Thank you, sir. Thank you, sir.
Yeah. Good night, guys. Thank you.
Good night, sir.
Thank you, sir. Thank you so much.